Okay, so we're back for part B here, just the tail end of the note. So as I mentioned, every time you go down a row in the periodic table, you get a new orbit. And with each family, all atoms have the same number of electrons in the outermost or valence orbit. The reason that calcium reacts faster than magnesium and beryllium, so to go to the periodic table, so calcium reacts faster than magnesium and beryllium. If you recall, I mentioned that over on the metal side of the periodic table, the further down you go, the more reactive. So beryllium is reactive, magnesium more, calcium more, strontium even more. What happened there? Barium and then radium, so more reactive as you go down. The reason is we know that in family 2 now that all the alkaline earth metals all have 2 valence electrons. Radium, though, it's 7 orbits away from the nucleus. Beryllium is only 2 orbits away from the nucleus. It's kind of like a gravity situation. So beryllium is the nucleus actually has a gravity, a little bit of a pull. Very, very minute because it's so small, but it has a little bit of a pull. And that's what holds the electrons in orbit, the same way that planets are held in orbit around the sun. Well, beryllium is so close to the nucleus that it's held a lot more tightly than magnesium, which is a little bit further away. And calcium is another orbit away, and strontium is another orbit away. So the further away these electrons are from the nucleus, the more easily they are pulled away by other atoms. And we'll be talking about that in another lesson. So that's what makes them more reactive, how much easier they are to be pulled away. All right. So calcium reacts faster than magnesium and beryllium because electrons are further away from the nucleus, so they have a weaker attraction to the nucleus. I've talked about valence shell already. This is the outermost orbit. So orbit and shell are interchangeable words, and outermost and valence are interchangeable. And valence electrons are the electrons in the outermost orbit. Oh boy, my fingers keep hitting things here. And so this brings us to the end of our note. We can see here 2 protons, 2 or 10, and 18. In the first orbit, we have a full 2. In this second atom, we have 2 in the first orbit and a full 8 out of 8 in the second orbit. And here we have 18 protons, which would give us 18 electrons as well. 2 in the first orbit, it's full. 8 in the second orbit, it's now full. And 8 in the third orbit, it's now full. The fact that these have full outer orbits tells me that these are our noble gases. And here's our 2, our 10, and our 18. When you have a full outer orbit, they are unreactive. We'll talk about this in another lesson, but the reason that things are reactive or unreactive is atoms always want to have a full outer orbit. Noble gases are happy. They have a full outer orbit. The reason why our alkalis are so reactive is an outer orbit would have 8, and they only have 1 electron in their outer orbit. If they can lose that electron, get rid of it, then they would have a full outer orbit. And it's really easy to lose 1 electron. That's what makes them so reactive. Our halogens over here, they have 7 out of 8 electrons in their outer orbit. If they could get 1 more electron from somewhere else, they would then have 8 out of 8 in a full outer orbit. And because it's easy to get just 1 electron, that's what makes them super reactive. Moving in, 2 in its outer orbit. So it would want to lose those 2. It's easier to lose 2 than gain 6. So it would lose 2. And then it would have a full outer orbit. It's easier to lose 1 than 2. That's why our alkalis are more reactive than our alkaline earth metals. Likewise, over here, oxygen has 6 out of 8. It could either lose 6 electrons to get a full outer orbit, or it could gain 2. And it's much easier to gain 2 than lose 6. So oxygen is a gainer. It would gain electrons to get a full outer orbit. It's a little bit harder to gain 2 more electrons than it is for fluorine to just have to gain 1 more electron. That's why fluorine is more reactive than oxygen. So if you recall, on our metal side, most reactive, second most reactive. Over here on our non-metal side, not reactive, full outer orbit. Most reactive are our halogens. A little bit less reactive, a little bit less reactive, a little bit less reactive, again moving in. All right, that is it. I'm also going to do a little YouTube video, and that should help clarify things for you.